Hi, today we're going to do slope. And slope is a new concept for most of you. It's something you've never probably heard about in a mathematical context. I mean, you know the slope of a slide or slope of a hill, slope of a toboggan hill, a ski hill, and you know that there's a concept of steep and shallow. You're all familiar with those. Today we're going to talk about slope as a mathematical concept. And slope is defined as the rise, which is the change in y, divided by the run, which is the change in x. So we write that as slope equals rise over run. Okay, rise is how far up it goes. Run is how far to the right it goes. Okay, so let's look at this one here now. These examples on this page, you can't see it so well on this screen here, but on your own printout you should be able to see that there are little dotted lines going up here and little dotted lines going across here. So our rise is we're going to count from this point right here and go 1, 2, 3. So our rise or our change in the y-axis is 3, and our change in the x is 1, 2, 3, 4, 5. So our slope is 3 over 5. That was pretty straightforward, right? This one's a little bit more tricky because our our rise this time, if we go from this point here, is 1, 2, 3, 4, 5, 6. But our rise is actually -6 because it's actually a fall, right? We're rising -6. And our run is 1, 2, 3. So that's 3. So our slope is -6 over 3. Which looks like a fraction, which means that we're going to reduce it, so it's equal to -2. Let me redo that without sometimes the pen just connects to the other thing. Okay, so -2. But I want to show you something else. It doesn't matter which point you start counting from, because if I started at the rightmost point on the slope that we're looking at, of this triangle that we've marked off, and I count my rise and my run, well, my rise this time is 1, 2, 3, 4, 5, 6. So the rise is 6, and the run is 1, 2, 3. But the run this time is negative. So our slope is 6 over -3, which also equals -2, right? So we still get the same answer. It doesn't matter which point you start at or end at, you will get the same answer. Just pay attention to that plus and minus. Another thing to think about is that a slope going like that, that's a positive slope. It goes up. That makes sense. A slope that goes like that, it's going down. That's a negative slope. Okay, and we think about how they're moving from left to right because that's how we read, that's how we count. So we do so many things in our culture, in our language. There's another thing I want to show you on this example too. It doesn't actually matter where on the line you look for your slope because the slope is a property of the line itself and it doesn't matter where you look. So let's pretend that our arrows were from here, this point right here, to this point right here. And it goes dot, 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 dot. My rise this time is -2 and my run is 1, so my slope is -2. So I get the same answer no matter where on the line I look for my slope. I do want to point out that the places I picked are what's called lattice points. I picked a place where the up and down grid line and the horizontal grid line intersects exactly with our graph, because that way I know that it's exactly that point. It wouldn't make sense for me to, for example, on example 1, I wouldn't want to pick this point because I don't know exactly what the coordinates of that point are. Okay, this one I do know that intersects exactly at this vertical line and this horizontal line, which don't have numbers because it really doesn't matter for slope what the actual numbers are because we're just counting lines, counting spaces. Okay, I hope that didn't confuse you. Okay, there are a couple of questions on this page that I usually end up helping all the students with. They're confusing. So what I want you to do is go ahead and try the rest of the page. You're probably going to run into trouble on 2 of them. So come on back to the video and pause the video, go do the work. When you run into trouble, come back and I'll help you out with them. Okay? Okay, let's look at example or question 5. There's no triangles drawn on this, or there's no arrows drawn on this one. So how do you figure out the slope? Well, remember when I said that it doesn't matter where on the line you pick your points. So I'm just going to pick 2 spots anywhere on the line. I'm just going to pick that one and that one. Really doesn't matter. Really doesn't matter. What's my rise? How far up or down do I go from this first spot point to this one? Well, 0, right? They're on the same level. So my change in y is 0. And my change in x is 1, 2, 3. So my slope is my rise over my run. Oops, I was going to write run because that's what I was saying. So it's 0 over 3, which equals 0. So my slope for this line is 0. And notice it wouldn't have mattered if I had counted backwards. I would have had 0 over -3, which is still 0. Okay, so that has a slope of 0. Okay, there's one more. See if you can do it. One more difficult one. Pause the video and come back. All right, question 7. That's the other difficult one. There are no arrows on it, so I'm going to pick any 2 points that are where I've got lattice points, right? Because that makes it easier. All right. What's my rise? My change in y? I'm gonna make it easy and use positive numbers. I've got 1, 2, 3, 4, 5. So my change in y is 5, and my change in x is 0, right? It doesn't change. It doesn't have a horizontal shift. So my slope is 5 over 0. However, remember the video of what happens when you divide by 0? The whole universe implodes. I think I showed you guys, or was it my other class? Okay, if you don't know what I'm talking about, let me know and I'll post the video for you because I think it's hilarious. It was a Lego movie, like a Lego stop action thing. Okay, anyway, 5 divided by 0 does not exist. The answer to this is undefined. Okay, the slope of that line, of a vertical line, is undefined. That is the answer. It does not have a slope. Okay, a horizontal line has a slope of 0, and a vertical line has no slope. Its slope is undefined. And I just want to show you a thing that actually Spencer, one of my kids, came up with, which I think is just brilliant for remembering this. You write wish upon a star. Okay, and so this is the star. Okay, and here's your upon. So U-P-O-N. So the U is for undefined because a line going straight up and down is undefined. This kind of slope is positive. A horizontal line is 0, and one going down is negative. Its slope is negative. How cool is that? I think that makes it really easy to remember. So you can put that in your pocket and do with it what you will. Okay, finish up that page and then come on back for the next one. Okay, this time it's slightly more difficult. I mean, just baby step, because you don't have the arrows this time. You don't have the triangle actually drawn for you, but the dots are still there. So you're just going to count from one dot to another dot. Notice the dots are all at the lattice points. So for example, 1, my run or my rise, you always count the rise first. 1, 2, 3, 4. So it's 4, 1, 2 over 2, which reduces to 2. Okay, that's it. You can do this page. Pause the video, do this page, come on back, do the next. So now we're on page 13, and I didn't give you the dots. You get to pick your own dots this time. Remember, you must use lattice points. So in question 1, there's a lattice point here. Oops, wish it didn't do that when I do circles. There's a lattice point here. There's one here. There's one here. There's one here. You can use any 2 of those to get your slope. Okay, so there's the triangle, or let's do this one. Those are both valid triangles to do. You will get the same answer no matter which one you use. Okay, just make sure you reduce it. Okay, and make sure you're checking your answers as you go. All right, I'm going to end this video there. Go do the homework, do the practice, and good luck.